There is not even a single country in the whole world which don't have dams. What is dam and how it works? Today I'm going to tell you that how dams build and what are the basic features which contribute in the construction of a dam. Use hydrostatic pressure to press the subscribe button to never miss any dam. To never miss any update. Dams have huge structures and specific geography. Generally, dams constructed where there is congested river surrounded by a high altitude mountain. Water streams towards the wall and stored unless dam overflows. People used to build dams over centuries. Oldest operational dam today is Lake Holmes Dam, which is operational right now in Syria, made by mummies up to 3000 before Christ. Mummy? No, made by pharaohs. What is it? Pharaoh from 1319 to 304 before Christ. Now, how dam is made? This is the very perplexing question which people ask, that how this huge structure sustains so much power that you cannot even imagine. There might be a couple of studies which involve in the construction of these huge structures. Number one is topology and number two is engineering. Topology? Hey teddy bear, make it right, this is topography. Okay. In topography, we analyze natural and artificial features of area around dam. For example, selection of a kind of environment, mountain, the kind of mountain is rocky, muddy, region at which the river is flowing, and the direction of the river, from where it comes from, and from where it goes, and all stuff are studied in topography. It is very much important in the construction of dam. In engineering, we have three majors which is equally important. Number one is civil engineers, number two is electrical engineers, and three is me, mechanical engineer. Yes, I am very proud of it. In civil engineering, we compute and project dams, inlet and outlet. We also inject with the concrete walls which used to store water with lesser turbulence. For example, there is a dam in Australia have a Pelton turbine in it. So the wall of the dam is curved. Water is focused on Pelton turbine to attain maximum output up to 92% efficiency. Mechanical engineers examine and design turbine forces of the fluid which is acting on each and every element of the wall or turbine. Water is stored in a dam and it exerts force on the wall which civil engineers build. Force has to be measured by the mechanical engineer, analyze that what is the amount of water stored in the dam and how much electricity produced. This can be calculated by me, mechanical engineer. So how can it be calculated? I am gonna tell you.
And this is the fluid, water, and this is your curved wall. And this curved wall, you see that fluid taking pressure on it, and pressure is just a force per unit area. This area is A. Now every Lorentz cross says that to solve mathematical problem, to cut it into a differential amount. For example, this is the area of the wall, whole area. So we cut this whole area into just a tiny differential dA. Pressure acting on this wall is dF. As you all know, basic knowledge of vector, every vector is to be divided into two. Some angle on the surface, the one is vertical component and the other is horizontal component, and this making an angle theta, which is the resultant force acting on this differential element dA is the sum of horizontal force in I direction plus the differential force in vertical J direction. This is your J direction and this is your I direction. This is very much science. It is very dangerous for you people just understanding how mechanical engineers compute force. So we neglect the horizontal component because it is just a force acting on this differential element in this direction. We just take the element with a vertical component. This fluid applying the force on this tiny differential element, water above exert big show amount of a force on it, force equal to the rho GV, and the rho is the density of the fluid which is constant, G is also the gravitational acceleration, and V is the volume. Volume we all know is area times height. So this column height and this differential area, the product of these two gives us the volume. So as the volume is A times H, we cannot increase area, we just increase the height of the column. So as this is your dam and this is your wall, so we have a thing thing in our hand is just to build this wall as much high to create much more vertical force on that particular element of wall, or in other cases of the turbine. This is the differential element on the turbine.
We don't use liquid aluminium just to power up your Netflix. Density remains constant. We don't shift our whole setup up to sun to just increase the value of a small g to just power up your late night shows. So we just change the height of the dam. It can be done by two steps: by choosing the high altitude mountains and creating a big wall or a tall wall around it to create more work from the turbine. So this whole fluid is pushed on a particular part of a turbine, enormous force, and this force rotates the turbine. What is in turbine? I will tell you. In the inside a generator, you have coil rotating in a magnetic field. So as water pushes that coil rotate inside a magnetic field to induces EMF. According to Faraday's law, electromotive force induced in a circuit is equal to negative of the number of turns on the coil multiplied by changing magnetic field with respect to time. What do you mean by changing magnetic field? Turn a coil into the conductor, the electric field lines from north to south are cut by it. So this cutting or this resistance induces a magnetic field in the opposite direction, right hand rule according to Lenz's law. Now electrical engineers uses transmission lines and powerhouses to control and manage electricity to power your houses and country. A unit cubic meter of water exerts tons of force on unit meter square of turbine if directly in touch. There is a famous saying of the civil engineer that लाइक करो, सब्सक्राइब करो और शेयर भी मारो इस वीडियो को. इंग्लिश बोल बोल के मुंह थक गया यार. अल्लाह हाफिज. चलो समझ आ गई होगी ना. चलो निकलो.